Hi everyone, it's Mr. Hamilton here. This video is all about what is a function. We're going to look at functions versus non-functions. We're going to look at domain and range, ordered pairs, vertical line test, and mapping diagrams. The goals of this video are as follows. We want to explain what a function is, and we want to identify if a relation is a function or a non-function in the following forms. We've got a table of values, mapping diagrams, graphs, ordered pairs, and equations. Notice that you can find a link to the note down below and you can fill that in as we go. So here's the first note. Data is two different forms. It is found in numerical forms and it is found in categorical forms. Numerical forms are only numbers, but categorical data is names, it's ratings. Maybe you're rating something on a hotel stay or something. It was fair, good, poor, that kind of thing. And then it could also be things like places. So basically anything that are words are categorical data. Numerical data, all numbers, categorical words. Ordered pairs are a collection of two objects. The order of the collection matters. And so, for example, I could give you something like 3 and 2, and that's very different than 2 and 3. Not the same. And so we graph those on the grid on the right, and you'll see that's in fact definitely the case. We always start by graphing the first number on the x-axis, and then we graph the next number on the y-axis. So the x-axis is down on the horizontal, and the y-axis is on the vertical. And so I've labeled those with the x and y coordinates as shown. And so you can see that 3, 2 is the first point graphed there, and 2, 3 is the next point I've just graphed. And so what you can see there is those are very different points. The order definitely matters. Now, you could also have ordered pairs that are not just numbers. You could have ordered pairs that are also words. So, for example, you could have George, Toronto. Maybe that represents a person and where they live. That cannot be represented on a graph, but it is still considered an ordered pair. Relations are the following. A relation is a set of ordered pairs. So it's more than one ordered pair. Only the numerical data can be done this way, right? Because the idea here is it can be something that's translated to a graph. So for example, we have shoe sizes and heights. So let's say we have a shoe size of 10 and that person has a height of 158 centimeters. And then you can see the next person has a shoe size of 11.5 and then a height of 175 centimeters, etc. The first variable is always the x variable. That's the independent variable. And the second variable is always the y value. That is the dependent variable. And so what we're going to do is we're going to put the x on the x-axis and the y on the y-axis. So go ahead and start doing that. Graph the graph, pause the video here, and check to see if you get the same graph that I get. All right, so here's the graph that I got. I've graphed all those things. It's a rough graph. It's not a perfect graph, but it's pretty close. And you can see the different points. The x-axis is graphed first, followed by the y values. What are domain and range? Domain is all the possible x values, and range is all the possible y values. So if we go back to the example we just looked at a minute ago, we can see that the domain is all the x values. We start with the smallest one. That's why I circled the 8 there. And we work our way up to the largest one. We always put them in order. And so the range is also going to be in order. It's not the same order. It's starting at 158 because that's at the lowest end. And we go all the way up to 175 because that's the highest value. So the order of the domain and range does not correspond with the data that we got. It's not in the same order. So that's important to keep in mind. So we always write them smallest to largest in the domain and range. One of the last definitions we want here, and this is the most important one in this lesson today, is what a function is. A function is a relation where every x coordinate, remember the x coordinate is the independent variable, every x coordinate corresponds to one and only one y coordinate. The y coordinate is the dependent variable. So we can only have one y value for every x value. In other words, there it is. One x value can not have more than one y value. One x value cannot have two different y values. Those are all different ways to say that, but one x value cannot have two different y values. That's the key. So let's look at what this looks like on a graph. We can talk about the vertical line test if something is a function. So if a vertical line can be drawn anywhere on the graph and only passes through the relation once, it's a function. If a vertical line can be drawn anywhere on the graph that it passes through twice or more, it is a non-function. So let's look at some graphs here and see what those look like. But first, let's just write that definition one more time before we look at those graphs. If a vertical line can be drawn anywhere on the graph and only passes through the function once, it's a function. So here are 6 different graphs we're going to look at and how this plays out. The first situation is just dots on a graph. You'll notice no dot is one above the other, so it's going to be a function. It passes the vertical line test. We draw a vertical line anywhere on that graph, it's only going to go through one point at a time. In this second situation, we have 2 dots that are one directly below the other. And so in that situation, that fails the vertical line test, and it is considered a non-function. We have 2 different y values that correspond to the same x value. The next situation here is a curve, likely a cubic. It's a function. There's no situation where the line would pass through twice. But if we have an ellipse or a circle or something like that, even though the one part at the left only passes through once, anywhere it passes through twice immediately disqualifies it as being a function. So now we look at a quadratic. This is a function for the same reason as before. And last but not least, we have a sideways quadratic, which fails the vertical line test again, so it is considered a non-function. Now, we can classify the first 2 graphs and the last 4 graphs as shown. The first 2 graphs are discrete functions. They are specific points on the graph, whereas we have continuous lines for the last 4. So those are the differences between those. Let's finish this up with just looking at 5 different ways to represent functions and non-functions. Now, the first situation here, we could have an x value of 0, 2, 4, 6 corresponding with the shown y values. And you'll notice that every x value has only one y value. So therefore, it is a function. So every x value corresponds to only one y value. And that's the key. Corresponds to only one y value. So what would this look like for a non-function? Well, it would be something like this. I could have an x value of 16, 9, 4, 1, and 0. And 0 might correspond with just 0, but maybe 1 corresponds with negative 1 and 1. See how it corresponds with 2 y values? Same with 4, it has 2 y values. 9 has 2 y values, and 16 also has 2 y values. And so this is a situation actually y squared equals x is the equation we'll look at later. But here we have some x values correspond to more than one y value. We only need one situation where that corresponds. Here we have 4 situations where that actually is the case. So now let's look at a situation of mapping diagrams. Mapping diagrams don't have to be something that is actually numerical data. It could also be categorical data, as we see in this example. So I have 4 types of cars, a Fit, a Civic, an Accord, and a 3. And those are made by 2 different manufacturers. They're made by either Honda or Mazda. And so the Fit is made by Honda, the Civic is also made by Honda, and the Accord is made by Honda. Mazda makes the Mazda 3. And so every arrow is only going from each x value once. That's the key. Only one arrow leaves from each or any input only once. And so what you see there, that is a function. We could also do that with numerical data. I could have 0, 2, and 4, and maybe outputs of 3 and 4. 0 and 2 could both give us outputs of 3. And that's allowed because we only have one arrow coming from each input value. 4 would give us 4, perhaps in this case. So only one arrow leaves from any input. So a situation where we would have a mapping diagram with a non-function is something like this. Let's say I had 16, 9, and 4, and the output values were the following. I have negative 4, 4, negative 3, 3, and negative 2 and 2. And so 16 leads me to negative 4 and positive 4, whereas 9 leads me to 2 outputs as well, as does 4. And so because we have 2 arrows coming from at least one of the input values, that means that is a non-function. More than one arrow from at least one input. That is the definition of a non-function. So what do graphs look like? We looked at a bunch a minute ago, but let me just give you 2 more quick graphs just to visualize this a little bit more. Here's one graph that goes through all 4 quadrants. And so in this situation, what we have is it passes the vertical line test. And so the VLT for short. Anywhere I draw a vertical line is only going to go through that graph once. It's not going to pass through it twice. Another situation where it's a non-function now is a situation like an ellipse or an oval, some of you might call that. And so there we can see it fails the vertical line test, even though the second line I've drawn passes the vertical line test. If it fails anywhere, that means it fails the vertical line test and is not a function. Last two things, ordered pairs and equations. So if we look at ordered pairs, here's a situation of ordered pairs. And if you go back to the example we looked at earlier in the lesson, you might remember the shoe size versus height. But this is the same idea. So we have 1, 3, 2, 3, 3, 3, 4, 2. Those are all points that, in this case, is a discrete function because it's those 4 discrete points on the graph. So here, every x coordinate corresponds with exactly one y coordinate. Now you might wonder, well, x when it's 1, 2, and 3 all give us y values of 3. That's fine. What we can't have is the same x value giving us different y values. And that's the definition of a non-function. So let's look at that one next. So for example, if I have 1, 3, and then I also have 1 again, but now it gives us a value of 2 on the y value, and again I have 1 and it gives us a value of 1 as a y value, I have that giving me 3 different values for the same x value, 3 different y values for the same x value. That would be considered a non-function. And it should have a curly bracket there at the end as well to finish off the set of ordered pairs. Any x coordinate corresponds with more than one y coordinate. It is considered a non-function. Last but not least, we're looking at some equations. So here's a situation, y equals x squared. That is a quadratic. So anything that has an x squared as the largest term is going to be a function. Another one might be x plus y equals 5, which at first glance you might be like, well, what is that? But if you rearrange it into y equals mx plus b, you can see that it's actually a linear function. So it's y equals negative x plus 5. Another situation might be a cubic or a quartic or bigger than that. And so it could be as big of a power of x as we want, but the idea is that we have y equals x to the third or y equals x to the fourth or to the fifth. And as big as we want to get, those are all going to be functions because they pass the vertical line test. So here's a situation that's a non-function. Y squared equals x. If you take the square root of both sides, you end up getting y equals plus or minus the square root of x. You might wonder why. Let's look at a specific example of why that's the case. If I have y squared equals 9, and I take the square root of both sides, you would agree, I think, that y equals positive 3. But if you think about it, I could also put negative 3 in for y. If I square negative 3, that's also positive 9. And so this situation that we're looking at here, this is why we always get a plus or minus. The situation that we're looking at is a sideways parabola. So be careful if you see a y that's squared or cubed. That's going to be a non-function. The next situation would be x squared plus y squared equals 25. That would be a circle. It could be equal to anything, any number, but x squared plus y squared equals something. But you'll notice both these situations fail the vertical line test and are non-functions. Thanks for watching. If you like this video, please like and subscribe, and check out the video right here about domain and range if you want more information about that.